DevOps and CI-CD Part 24. This episode has 4 questions. For each question, take a moment to think through your own answer before I share a strong approach. Question 1. Explain continuous deployment. Here's a strong way to approach it. What is continuous deployment? Continuous deployment is a software delivery practice where every code change that passes all automated tests and quality checks is automatically deployed to production without any manual intervention. It is the final stage of CI/CD automation. How it works: developer commit, build application, run automated tests, code quality checks, security scans, create artifact or Docker image, deploy to production automatically. If all stages succeed, the application is released to users immediately. Example: suppose a developer fixes a bug and pushes code to GitHub. 1. CI pipeline is triggered. 2. Application is built. 3. Unit and integration tests run. 4. Security and quality scans pass. 5. Docker image is created and pushed to a registry. 6. Kubernetes deployment is updated automatically. 7. Users receive the new version without any manual approval. Benefits: faster release cycles, reduced manual effort, immediate delivery of features and fixes, lower deployment risk through small, frequent changes, consistent and repeatable deployments. Challenges: requires strong automated testing, rollback mechanisms must be in place, monitoring and alerting are critical. Defective code can reach production if tests are insufficient. Common techniques used: canary deployment, release to a small percentage of users first. Blue-green deployment, switch traffic between two environments. Rolling updates, gradually replace old application instances. Automatic rollback, revert if health checks fail. Tools commonly used: Argo CD, Jenkins, GitHub Actions, GitLab CI/CD, Spinnaker. Real-world example: Kubernetes. Developer pushes code, GitHub Actions, build Docker image, push to registry. Argo CD detects change, deploy to GKE or X. Health checks pass, release. Live interview. Answer: 1 minute. Continuous deployment is a DevOps practice where every code change that successfully passes build, testing, quality, and security checks is automatically deployed to production without manual approval. It enables rapid and frequent software releases while reducing human intervention. To implement continuous deployment effectively, organizations need comprehensive automated testing, monitoring, and rollback mechanisms. In Kubernetes environments, tools such as Jenkins, GitHub Actions, Docker, and Argo CD are commonly used to automate the entire deployment life cycle. Nice. Let's continue. Question 2. What is continuous delivery? Here's a strong way to approach it. What is continuous delivery? Continuous delivery, CD, is a software development practice where every code change is automatically built, tested, and prepared for release to production. However, the final deployment to production requires manual approval. The goal is to ensure that the application is always in a deployable state. Continuous delivery flow: developer commit, CI pipeline, build application, run tests, code quality checks, security scans, create artifact, deploy to staging or UAT, manual approval, deploy to production. Example: a developer pushes code to GitHub. 1. Jenkins or GitHub Actions triggers the pipeline. 2. Application is built. 3. Unit and integration tests run. 4. Security and quality checks pass. 5. Docker image is created. 6. Image is pushed to a registry. 7. Application is deployed to a staging environment. 8. After business or QA approval, it is deployed to production. Benefits: faster and more reliable releases, reduced deployment risk, consistent deployment process, early detection of issues, easy rollback and release management. Continuous delivery versus continuous deployment. Feature: continuous delivery, continuous deployment, production approval required, not required, human intervention, final deployment only, non-release control, more control, fully automated, risk lower, higher if testing is weak. Common tools: Jenkins, GitHub Actions, GitLab CI/CD, Argo CD, Azure DevOps. Real-world example: in a Kubernetes project, code commit, the exact commands and code are in the written question bank. Great. Moving on. Question 3. Explain GitOps. Here's a strong way to approach it. What is GitOps? GitOps is an operational framework that uses Git as the single source of truth for both application deployments and infrastructure management. Instead of manually deploying changes to Kubernetes or cloud environments, you make changes in Git, and a GitOps tool automatically synchronizes those changes to the target environment. Core idea: if it's running in production, it should be defined in Git. Git stores Kubernetes manifests, Helm charts, Terraform code, application configurations, infrastructure definitions, GitOps workflow, developer change, Git repository, pull request, review, merge to main branch, GitOps tool detects change, sync to Kubernetes cluster, application updated. Example: suppose your application is running with 3 replicas. 3. You want to scale it to 5 replicas. 1. Update the YAML file in Git replicas. 5. 2. Create a pull request. 3. After approval, merge it. 4. GitOps tool detects the change. 5. Kubernetes cluster is automatically updated to 5 replicas. No manual kubectl apply is needed. Key principles: 1. Git a source of truth. The desired state of infrastructure and applications is stored in Git. 2. Declarative configuration. Infrastructure is described declaratively. Example: replicas. 3. Image, app, v1. 3. Automated reconciliation. GitOps tools continuously compare desired state, Git, actual state, cluster. If drift occurs, they automatically correct it. 4. Pull-based deployments. The cluster pulls changes from Git rather than external systems. Pushing changes. Benefits: checkmark version control for infrastructure, checkmark easy rollback, checkmark audit trail of all changes, checkmark faster deployments, checkmark reduced manual errors, checkmark improved security, checkmark drift detection and correction. Popular GitOps tools: Argo CD, Flux. GitOps versus traditional CI/CD. Traditional CI/CD GitOps pipeline pushes changes to cluster. Cluster pulls changes from Git. Deployment state may differ. Git is always the source of truth. Manual kubectl commands possible. All changes go through Git. Limited auditability. Complete audit trail. Real-world example: GKE. Developer GitHub repository, pull request, approval, merge to main. Argo CD watches repository, syncs changes. GKE cluster updated if someone manually changes a deployment in GKE. Kubectl scale deployment app. Replicas equals 10 but Git says replicas. 5. Argo CD detects the drift and automatically reverts the cluster back to 5 replicas. Interview answer: 1 to 2 minutes. GitOps is a deployment and operations methodology that uses Git as the single source of truth for infrastructure and application configurations. All changes are made through Git pull requests, reviewed, and merged before being applied. A GitOps tool such as Argo CD continuously monitors the repository and synchronizes the desired state stored in Git with the actual state of the Kubernetes cluster. This approach provides version control, auditability, automated rollbacks, drift detection, and consistent deployments. In production environments, GitOps helps improve reliability, security, and operational efficiency by eliminating manual deployment steps. Alright, next question. Question 4. What are GitOps principles? Here's a strong way to approach it. GitOps principles. GitOps is based on 4 core principles. 1. Declarative configuration. The entire system, applications and infrastructure, should be described declaratively. Instead of writing commands like kubectl scale deployment app, replicas equals 5, you define the desired state in a file, API version, apps or v1 kind, deployment spec, replicas. 5. This makes the infrastructure reproducible and version controlled. 2. Git is the single source of truth. All infrastructure and application configurations are stored in Git. Examples: Kubernetes manifests, Helm charts, Terraform code, application configurations. Every change must go through code change. The exact commands and code are in the written question bank. Let's keep going. That wraps up this episode. Nice work practicing, and see you in the next one.